How to dissect a preserved cow eye. This video provides instructions on how to dissect a preserved cow eye and identify its key external and internal anatomy. To begin, clear the area that will be used for dissecting. Dissection should be performed on a flat surface. Make sure that the area being used is clear of all clutter and personal belongings. Next, you'll need to obtain your materials. The materials needed for this dissection include rubber gloves, a dissecting tray, a dissecting tools kit, Lysol and paper towels, and of course the preserved cow eye. A kit including the following tools will be needed to perform this dissection. Beginning from the left, you will need scalpels. There are two different sized scalpels, both a large blade and a small blade, depending on the type of tissue you are dissecting and the size of the specimen. Next, you'll need forceps. There are two different types, both straight and curved. Third, you will need scissors. Again, there are also two types, straight or curved. Next, you'll need a hemostat, which can be locked into place for grasping certain tissues. Last, you'll need various probes. There are sharp and blunt probes, and they can also be straight or curved. These can be used to isolate structures while dissecting. Before handling the cow eye, you will need to put on a pair of rubber gloves. When choosing your glove size, you want them to form-fit your hands so that you can properly use the dissecting instruments. As you can see here, there are no wrinkles and the gloves fit properly. Now you may obtain a preserved cow eye. Place it on the dissecting tray and take it back to the dissection area. Once you have gathered all of your materials, the dissection can begin. We will now be able to identify the external structures of the cow eye. We will begin with the front of the eye, which is covered with the cornea. The loose white tissue surrounding the cornea that can be pulled up is called the conjunctiva. The brownest tissues seen here are called the extrinsic or extraocular eye muscles. They are skeletal muscle tissue that help move the eyeball. The yellow material seen here is adipose tissue. Commonly known as fat, it insulates and protects the eyeball. The last structure to be seen from the exterior is the sclera. In order to view the sclera, you have to remove a portion of the conjunctiva using the curved scissors. In a live specimen, the sclera would be very white. However, here it is a grayish color. Now that the external structures have been identified, the excess muscle and adipose tissue can be removed. The curved scissors are a great tool to use since the eye itself is round. The main reason for removing these tissues is so that we can visualize the eye as a round structure. It is important to preserve the optic nerve, seen here, when trimming away the tissues. Here we have a better view of the optic nerve. Once the optic nerve is isolated, all that remains is removing enough tissue in order to open up the eye. To review what we have covered so far, the external structures of the eye consist of the cornea, the conjunctiva, the layer directly underneath the conjunctiva known as the sclera, and finally the optic nerve. Now we can continue dissecting the eye to identify its internal structures. Begin by making an initial incision into the eye using a scalpel. There are two different methods for cutting the eye. You can continue using the scalpel or insert the scissors to cut around the eyeball. You will want to make your cut equal distance from the cornea around the entire eyeball. The size of each eyeball will vary, but the cut needs to be around a ½ inch away from the cornea. When cutting, hold the eyeball firmly. As you near the end, grasp it using the forceps. Now we can start to identify the internal structures. This is the front of the eye, where the cornea lies underneath. And this is the back of the eye, where you can see the optic nerve. Inside the back of the eye is a yellowish-gray layer that is able to be peeled back. This is the retina. Next you will see a little point known as the optic disc. The optic disc is where all of the retina nerve fibers come together and exit the eye as the optic nerve. When you peel back the retina, you reveal the next layer known as the choroid. This layer, which is black or a dark brown, is the vascular structure, supplying blood to the eye. You may begin peeling back the retina. You will notice it remains attached right at the optic disc. Since this is a cow eye, you will see an area of iridescence that is a portion of the choroid. This is called the tapetum lucidum, which is found in nocturnal animals. It allows for even a small amount of light to be reflected, allowing them to see at night. Although seen here in the front of the eye, this thick gel-like substance called the vitreous humor fills the back of the eye. It acts as a refracting medium for light entering the back of the eye, and its gel-like consistency helps the eyeball keep its shape. Once the vitreous humor is carefully removed, we can continue identifying the structures found in the front of the eye. The firm, round structure seen being removed here is the lens of the eye. In a live specimen, the lens would be clear. However, due to the preservative used, it has a cloudy appearance. The liquid seen here filling the front of the eye is the aqueous humor. If you look carefully, you will see a circle between this structure here and this structure here. This is where the lens sat and attached itself to these radiating hair-like structures called the ciliary body, which control the lens. The darker area seen here without the lines is the iris. It is the colored portion of someone's eye. And then the hole in the iris is the pupil. To summarize how light travels through the eye, it first enters through the cornea. It then passes through the anterior chamber full of the aqueous humor. Then through the pupil and the iris. It then passes through the lens and continues through the vitreous humor in the back of the eye. And finally to the retina, where the nerve impulses of light are translated and sent through the optic disc, through the optic nerve to the brain. Now that we have successfully completed our dissection, all that remains is cleaning up. Because the eye is preserved animal waste, it can simply be thrown away in the regular trash. Next, you will want to collect all the tools you used and wash them off. Using warm water and soap, carefully put a small amount on each one and clean the entire instrument. Pay special attention to the tips of the instruments where they may have touched the specimen. Once the instrument is cleaned, rinse it off and place it on a paper towel to dry. Continue until all the instruments are clean. You will then want to hand dry each piece and replace it in its designated spot in the dissecting tools kit. Last step in cleaning up is to use a dilute Lysol solution to thoroughly clean the surface area. Thank you for watching this video. I also want to thank Dr. Nodzak for starring in this video and for all of his help.